It's 8 a.m. in Jakarta, 9 p.m. Eastern Standard Time. So maybe we'll start. Selamat pagi semua orang di BPS. Pak Kadarmanto, I see you there. Good morning to you. I hope you had a good restful weekend.
Yeah, morning, Pak.
Morning, Pak Gareth.
Yeah, I see. Yeah, Pak Habibullah, nice to see you. Thank you for joining. Today, we will move to the online trainings between BPS and the National Agricultural Statistics Service from USDA, which we call NAS for short. And so just like with the GATIS training, this training was supposed to be in person in Indonesia. And so for everyone joining, I just want to say again that we will still plan to have our NAS colleagues visit Indonesia as soon as that is possible to deliver more in-depth, detailed training and to work with BPS in person. So this is not meant to cover everything. This is just meant, this series of trainings, which are focusing on area sample frames and on remote sensing, are meant to be just an introduction. And the first part of this series is designed to be an opportunity for BPS to share with NAS about their current methodologies and practices in the field of agricultural statistics. So I'm sure that Sarah and her colleagues will have additional questions. And so I think we should make sure that there's time for that to happen, because that exchange is very important. It's not so easy when we're not in person, but it's definitely essential to sometimes understanding how each side is operating. After this session, my colleague Ugi, who is joining us, will be sending out another email with the invitation for the next training, which is on Thursday, July 23rd, Jakarta time. I would just like to say at the beginning that working from the US Embassy side and working with my colleagues in the Foreign Agricultural Service and NAS in Washington, DC, we're very grateful and very much support the recent work that BPS has engaged in with regards to refining the methodology used for paddy production in Indonesia. We understand that it's a very large undertaking and that there are a lot of complexities to reporting on this crop in particular, and that it's also vitally important to Indonesia to have functioning, clear, transparent, high quality statistical data on paddy production. So I would just like to commend BPS for the work that you have done on this effort. And with that, I would like to ask if Pak Habibullah, if you would like to say a few words before I introduce our trainers and colleagues from NAS.
Yeah. Thank you, Gareth. Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone in Indonesia, and a very good evening for the USDA team in the US. Once again, I would like to thank Pak Gareth and the USDA team for facilitating this meeting, following our successful training on GATIS last week. Today, the BPS team is going to make presentation on the implementation of the area sampling frame, or ISF, or Indonesia in Bahasa Kerangka Sampel Area Method to estimate paddy harvest area in Indonesia. They are going to share with the USDA team our experience in improving the paddy statistic in Indonesia using the method. As you have noticed, paddy or rice is essential food commodity in Indonesia. Therefore, rice production data obtained from a sound methodology are strongly needed for policy and decision making. For the implementation of the SF method, rice production data has suffered from overestimation because because of the use of subjective measurement, so-called I estimate and estimating the harvest area. However, thanks to the implementation of the ISF method, rice harvested area data obtained from an objective measurement have been provided for the rice production computation for the first time since 2018. Hopefully, from the BPS presentation, USDA team can get a brief understanding of ISF method implemented by BPS. I noticed that USDA has a long experience in implementing the sampling area frame from crop estimation in 1958, if I'm not mistaken. Of course, there is no one single perfect method when it's come to crop area estimation. The sample applies to the ASF method that we have implemented. That is why, from the presentation, we are more than happy to make any comment and advice from the USDA team based on your experience to improve our ASF method in the future. For your information, we would like to implementation the same method for the maize production. I think that's all from me. Have an enjoyable discussion. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Gareth.
Yep.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Habibullah, for that introduction. I would like to start by giving just a brief introduction about NAS and the work that they do. I included some information on the invitation that was sent to BPS. NAS is the premier agricultural statistics agency globally. It provides timely, accurate, and useful statistics to service U.S. agriculture, but it also conducts a lot of trainings worldwide and works with many other countries to improve their agricultural statistics performance. In the US, NAS conducts the Census of Agriculture every 5 years. They issue hundreds of reports and have many thousands of employees who gather the data and who go out, visit farms, and not just the people who are sitting back in Washington. So it's a big undertaking that they undergo every month, looking at the US agriculture. Today, our trainer, the lead person on this program for NAS is Ms. Sarah Hoffman. Some of you may remember Sarah or may have met her before. She has worked in Indonesia several times, most recently in September of 2019, where she co-led a mission with her colleague, Mark Miller, and they came and worked with BPS on pricing statistics. So that is actually what led to this series of trainings. And we were all very grateful for BPS hosting us back in 2019. And that really was the start of all of this. So Sarah has been there from the beginning on that. She is a mathematical statistician who works in the international program at NAS. And she's been there too long to mention. I'm not even going to mention. I don't want to. But she has been a great resource for the embassy, and I think she will be a great resource for BPS in this. And so with that, Sarah, I'll turn it over to you for how you want to, if you want to say a few words. And I understand that Pak Kadir, I believe, will be leading some of the discussion for the BPS side. I do just want to mention that, unfortunately, I have a call with Pertamina that I will have to join in a little bit. So I do apologize for leaving the meeting earlier. I will try to join the meeting when I'm finished with that call. But you're in about the best hands you could be with Sarah. And so Sarah, I will turn it over to you.
Thank you very much, Garrett. Pressure's on now after all those words of praise. But yes, I have worked in Indonesia before, and I truly, truly wish I could be there with you in person. Tonight, we begin our sessions on area frame and remote sensing. And in order to facilitate the exchange, I have gotten the assistance of our spatial analysis research section. So most of our presenters will be from that group. We'll be able to tap into their knowledge and their experience of working on and creating the area frame and all the remote sensing programs that NAS uses. I think I'll wait to introduce each one when they're actually going to be doing their presentations rather than take 20 minutes and do that now. But I did just want to say that we are happy to be working with BPS again. We look forward to seeing you guys in person, and we look forward to learning about what systems you're using now for your area sampling frame. So thank you, Salamat Pagi. And Pat Kadir, I believe the mic goes to you.
Yeah, thank you, Sarah. Thank you. Hopefully everyone can hear my voice clearly. Yeah, thank you. Selamat pagi. Hello, everyone. My name is Kadir. Yeah, I am from BPS, the presenter today. Good morning to all of you in Indonesia and good evening in this. Let me share my screen so everyone can see my slide. Please wait a moment. Today, we are going to share with you, especially the USDA team, our experience, BPS experience in implementing the area sampling frame for the estimation of paddy harvest area in Indonesia. As my deputy chief statistician, Pak Habibullah, said before, the main objective of this meeting, actually, this sharing, is just to give some, maybe a brief understanding to USDA team what we have done in Indonesia so far in implementing area sampling frame. So in the next session, especially when USDA team presenting their work, there will be a more discussion, because you have already understand what we have done in Indonesia so far. Actually, these slides were prepared by the Subdirectorate of Food Crop Statistic teams. There are many people with me actually in preparing this slide, and they are joining the meeting this morning, and they will help me to take any question from you. Yeah. Okay. This is the outline of my presentation today. I'm going to make a start by explaining the paddy statistic collection system in Indonesia, just to give you some understanding about the background, especially the background and the motivation why we implement the area sampling frame to collect a paddy statistic in Indonesia. And then I'm going to explain a little bit more about the method, the technicalities. I'm going to start with the frame construction, sample selection, observation, and so on. And also I will give you some explanation about the issues around the implementation of the method and our future plan in developing the method in the future. This is the summary of rice data collection system in Indonesia. Basically, in computing the rice production in Indonesia, we just need two kind of variables, namely rice harvested area and the yield or productivity. Yeah, to get production figure, we just multiply the two variables. Yeah, the two variables. in the past, there are some issues. There were some issues around the rice harvested area. Yeah, the main problem is the method that was used to collect the harvested area data. Yeah, in the past we rely on what we call a subjective measurement method. Yeah, people on the ground use eye estimate, eye observation to predict, to estimate the area of the harvested area, yeah, in the paddy field, yeah. That's one point. The other one is the data the data were collected by other institution, not BPS itself. Of course, there were issues about interest here, vested interest, because the data were collected by, we call it district agriculture service officer under the coordination of the Ministry of Agriculture. At the time they had interest on the data because they use the data for, as you know, for monitoring and evaluation their program in trying to improve the production of paddy. So there is an issue about independency here. That's why since 2018, we try to improve the methodology. Yeah, we try to solve those problems by implementing the area sampling frame. Yeah. So as my deputy chief statistician said before, since 2018, we have solved the problem by having an objective measurement in collecting harvested area data or statistic. And in terms of yield, actually, there is no a significant problem in terms of when it comes to yield or productivity, because since for a long period of time, we have implemented what we call probability sampling survey. So in terms of statistical methodology, there is no significant issue around the productivity, yeah, because we use probability sampling here, and we conduct what we call crop cutting survey or ubinan in Bahasa to measure the productivity. However, in the past, one of the limitation of this method, it was we rely on what we call household survey, yeah, household survey. So we need a list frame in developing the survey, in implementing the survey. And based on our experience, this was one of the limitations in the past in terms of the speed of data reporting and so on. Yeah? And that's why from the result of the area sampling frame that we already have, we can improve also our productivity measurement. Yeah? We try to integrate the area sampling frame in our crop cutting survey. Integrating mean that we use the result of ASF as our sampling frame in conducting crop cutting survey. Also, maybe you already know that paddy and rice in Indonesia are totally different things. You know, I mean that to compute the rice production, we need some what we call conversion rate, yeah, to convert paddy to rice, yeah. And we also have we have done some improvement. We have updated some conversion rate to convert paddy to rice in also in 2018. And actually, the implementation of area sampling frame in Indonesia is a product of collaboration of some government agencies. In this regard, BPS Statistics Indonesia didn't work alone, because in implementing the area sampling frame, in developing the new method, we need many expertise that BPS doesn't have, yeah, especially related to geospatial stuffs and other things that we don't have expertise on it, yeah. There are 5 government agencies got involved in the development of area sampling frame, namely BPS, Agency for the Assessment and Application of Technology. This is my main partner in developing the area sampling frame, BPPT. Also, there are Geospatial Information Agency, Ministry of Agrarian Affairs and Spatial Planning, or National Land Agency, and our Space Agency, or LAPAN. Yeah, each of them contributed to the development process with their own expertise. Yeah, for example, LAPAN provided us with a high resolution of satellite imagery. BPPT very helpful. They was very helpful in terms of methodology and so on. Yeah. So the work actually is a product of collaboration of several government agencies. Now we move to the technicalities of the area sampling frame that that is implementing by BPS. This chart illustrates, summarize the process of constructing sampling frame and sample selection in the implementation of area sampling frame in Indonesia. So we start with preparing, collecting, we call it data inputs. There are several data inputs in constructing sampling frame, namely all of them are maps. Yeah, there are topographic map, administrative map, paddy field map, land cover map. That's why we need collaboration with other government agencies, because BPS traditionally we only conduct census and survey, mostly households approach, and we don't have any resources related to all these maps. So that's why we need a collaboration, and we got all those input from other government agencies that I have mentioned before. Yeah. After that, we call it stratification. Yeah, we stratify the paddy field into 4 distinct categories. I'm going to explain this process a little bit more detail later on. In summary, we try as to stratify the paddy field into 4 distinct categories or groups, namely non-paddy, irrigated paddy, non-irrigated paddy, and dry land. Yeah. Why we need a dry land? Because in Indonesia, the cultivation of paddy is not only conducted in wetland, but also in dry land. There is a specific type of paddy that is cultivated in dry land. After that, we call it grading process. Grading process. Grading means we construct grids, and then we divide each of the grid into sub-grids. Yeah, we call grids as block and subgrids as a segment. Yeah, the size of each grid is 6 kilometers times 6 kilometers, and in each grid there are subgrids with size 300 meters times 300 meters. Yeah. After grading process, after we divide our area of study into grids and subgrids, we then construct what we call a sampling model. Yeah, we call it sampling model. We will use this sampling model to do what we call segment extraction. Yeah, when we construct the sampling model, we apply a systematic random sampling method. Yeah, with a certain specific rule. We call it, I don't know exactly, if I am not mistaken, threshold. There is a distance threshold in implementing in implementing the sorry, maybe I have a problem with my screen. I can't see my screen. Maybe. Does everyone can see my presentation? Sorry, Sarah,
Yes,
maybe you can help me.
Yes, the screen we're looking at right now says constructing sampling frame and sample selection on it.
Okay, yeah. Thank you, Sarah, for your help. Yeah, and yeah, we use systematic random sampling actually in creating what we call sampling model. Yeah, for sample segment extraction. Yeah, as I said before, that we apply what we call, there is a threshold distance. By the distance, we set that the distance between the two segment no more than 1 kilometer, I think, yeah. And after we have a sampling model for sample extraction, we apply the sampling model to our uh, our our grids, yeah, our grids, yeah. I'm going to explain this process a little bit more detail later on. After that, we overlay the certification result and the replication result, yeah. And then from that, we do sample selection again to get a sample segment that we are going to, that we will be observed by our surveyors, yeah. And each sample segment has ID, so ID and what we call geospatial attribute. So everyone, our surveyor, can identify the location of the each sample segment on the ground precisely. Yeah, and one of the benefit using geospatial information is each of our sample segments, because each of them has coordinates, so we can log the coordinate. So the observation only can be done when, not only the observation, the reporting of the result of observation only can be done when our surveyor is in the location, in the right location, the coordinate. Yeah. Yeah. Regarding the certification process, I'm going to explain a little bit more detail about the certification process here. As I said before, we stratify our rice field, yeah, into 4 categories. Yeah, yeah. The first one, we call it stratum 0, yeah, consisting non-paddy field polygon. Yeah. For example, forests, plantation, ponds, bodies of water, housing, etc. Yeah, this stratum will be removed from the sampling selection. So, and the second stratum is stratum 1, is irrigated paddy field polygon. Yeah, which include those cultivated once a year, twice a year, or more. Yeah, it depends on the condition in the field. Yeah. All segments in this stratum have possibility to be selected as our unit observation or our samples. Yeah? And the third stratum, stratum 2, non-irrigated paddy field polygon. Yeah, in the case of Indonesia, not all of the paddy field have irrigation system, so we have to create this stratum to accommodate non-irrigated paddy field polygon. Yeah, this stratum consists of rain-fed paddy fields, tada hujan in Indonesia, which only planted that during the rainy season. Yeah, the planting activity really depends on the season, because they don't have irrigation system. And the last one is stratum 3. This stratum consists of possible paddy field polygon, possible paddy polygon, whereas in practice is dryland polygon. As I said before, in Indonesia, the cultivation of paddy is not only conducted in wetland, but also in dryland. In creating this stratum, we impose some assumptions. The first one, it is possible for farmers to plant rice in dryland with go-go system, as said before. Second, generally, dry fields are close to paddy fields, so there is a possibility of usage conversion. And the third, narrow paddy fields mixed with dry fields might not be mapped on a standard paddy field map with a small scale, and generalized into dryland polygons. That's all assumption that we impose when constructing the stratum 3. This is the example, the illustration. This figure, this image illustrates the result of stratification process in Jawa Barat or West Java province. As you can see on the slides, there are a color composition here, the result of stratification. The green one is irrigation rice field. The blue one is non-irrigation rice field. The red one, possible rice field. In practice is dryland arable. And the white one, non-agriculture land, and no segment sample in the white color. How about the grading process? This is the mechanism of doing grading process. Our area of study is divided into square block of 6 kilometers times 6 kilometers. After that, each square block is further divided into square segment, of 300 meters times 300 meters, The boundary of the segment is based on the geographical coordinate with fixed location. So as I said before, we have georeference information for each segment, So we call it segment, we call it segment. Subgrids with size 300 meter times 300 meters, we call it a segment. And this is actually our unit of observation that will be visited by our surveyors when they are selected as a sample. This is the illustration of random model that we use. This is the result of constructing the random model, 5% of systematic random sampling. So because we only select 5% of segments in each block or grid, there will be 2 segments, are selected among 400 segments in a square block, and then we do replication. We apply this random model to each block or a grid, this is the illustration of the replication process. We apply the random model that we have constructed in the previous stage to each block that we already have. This is the illustration of the result of replication. You can see we have put our random model to each. We have fill in our random model to each block, and the result like this. Yeah. After that, we do sample selection, and then before we do sample selection, we overlay the result of replication with the result of stratification. Yeah, and as you can see, the outputs is like this. Yeah, we have combination of colors representing the strata, and also we have some dots, yeah, which are the result of replication of the random model. And when we have this kind of picture, we then do sample selection. We select only 1%, yeah, of the sample segment, proportional to the size of paddy area in sub-district systematically. Yeah. Yeah, this is the final result of the sampling frame construction. Yeah. In this stage, we have all sample segment that will be our unit of observation, that our surveyor will make a visit to make observation on this segment, yeah, regularly. Yeah. This slide illustrates the mechanism, yeah, how we do observation. Yeah. Actually, in each selected segment and then further divided into 9 subsegments of 100 meters times 100 meters, our surveyor will make a visit and do observation to observe the growing pace of paddy. Yeah, the location of the observation must be in the center point of each subsegment. But somehow we try to tolerate sometimes our surveyor have difficulties to reach the center point of the subsegments. To accommodate the kind of condition, we also tolerate the observation around the center point, as long as the location is in the radius. We call it the radius. Yeah, I think 10 meters from the center of the point of observation. And our surveyor, each of them brings their own device in conducting field observation. So there is a spatial application, Android-based application that is installed in their gadget. So they can use their own gadget with Android-based application specifically dedicated for area sampling frame observation. Yeah, so we built application dedicated for the observation process. As you can see on the screen, yeah, this is the illustration of the screen of the application on the our surveyor gadget. Yeah, this is the more illustration about the observation process. Yeah, as I said before, our surveyor make a visit to the sample segments, and each sample segments consists of 9 subsegments, and then they do observation on each sample subsegments, visiting the center point of each subsegment. Yeah, this is the illustration, the way our surveyor, takes picture and do observation. Yeah, they they come to the center of the subsegment and taking picture. Yeah, actually the picture will be used for monitoring sake. Yeah, for the monitoring purpose. Yeah, we will use the picture that our surveyor take to verify the consistency between the growing pace of paddy that our surveyor reported and the picture. Yeah, I'm going to explain this a little bit more in detail later on. But from this slide, we want to explain to you that this is the process. There is an application, Android-based application, and our surveyor used their own device, yeah, taking picture and sending, yeah, the result of observation to our server. In application, there are some features to guide our surveyor in conducting observations. So they will know, yeah, whether they result have been sent or reported to our server or not. Yeah, and actually we observe a lot of number of sample segments. Yeah, for example, in February 2020, we observe 24,000, more than 24,000 segments. Yeah, it means that there are more than 200,000 observation points. Yeah, that visited that were visited by our surveyors. Yeah. On the ground, in each sample segment, in each sub-segments, our surveyors will observe this kind of information, will record this kind of information. Yeah, namely vegetative one, the condition, the circumstances of paddy vegetation. Yeah, in each subsegments, in each subsegment. Yeah, there are vegetative one, generative, vegetative two, harvest, land preparation, and also, of course, there are possibility that our surveyor will find other condition, yeah, on the paddy field. Yeah, maybe there are damage, yeah, or the paddy field are planted by other commodities other than paddies. Yeah, also maybe it can be happen that our subsegment actually, especially in the center point of the subsegments, is not the paddy field. Yeah, as you can see on the picture. Yeah. How about the reporting schedule? Yeah, this is the observation timetable. Yeah, we conduct our surveyor conduct the observation in the last 7 days every month. Yeah, in the last 7 days every month, and then after that, the result will be validated by our supervisor in the 5 days after the following months. Yeah. So the validation process involve a lot of process there to make sure that our surveyor have collected the right information that we need. Yeah. So in this regard, actually, we have a monitoring system with website. We use website monitoring system to facilitate this process, this process of validation by our supervisor. Yeah. And after that, day 6 to 10 of the following one, we go with data processing to estimate the area of paddy, particularly the harvested area. Yeah, web-based monitoring system to facilitate validation process after the observation. So after the information or the data sent to our server by our surveyors, our supervisor will conduct validation using some tools in this website. Yeah, actually, yeah, as I said before, this website facilitates us with many features. Yeah, not only for doing validation to check the consistency between the picture and the information reported regarding the growing pace of the paddy, but also we can monitor. Yeah, we can monitor the progress of the survey, yeah, on a regular basis. I think near real time, I can say like that. Yeah, we can monitor, yeah, the process at time to time, yeah, to make sure that our data collection process, our survey runs smoothly. Yeah, this is the illustration of the validation process using the website. Yeah, so our supervisor can check the observation result of each surveyor under his or her responsibility by using this website. Each of them, our supervisor can match, yeah, can check the consistency between the picture and the the growing pace of paddy reported by his or her surveyors. If our supervisor find inconsistency here, unmatched things like that, they will send some kind of feedback to their surveyor to make any correction and sending back their observation result. Yeah, about data processing estimation. Yeah, actually, uh, we use simple method here. We just estimate the proportion, yeah, from the observation results sending by our surveyors. We calculate the proportion, yeah. So in doing that, we define what we call random variable with two outcomes, yeah, for each growing pace, yeah, for each growing pace. So based on this variable, we can then calculate the proportion of each growing pace of paddy. Yeah, you can see the illustration on the screen. Yeah, how we transform the information into the code. Yeah, the binary code. Yeah, for example, this one is the illustration for generative growing pace. Yeah, so we assign one for when generative happens and zero otherwise, and the result of data processing like this. Yeah, every square with in the field, the square means the subsegment. Every square with generative growing pace of paddy in each, we assign one, yeah, and zero otherwise. Yeah, and the result like this. After that, we calculate the proportion, yeah, the proportion. Here we divide by 9, yeah, because there are 9 sub-segments in each segment, yeah. We do this process for each sample segment, yeah. We do this process for each sample segment, and actually the process kind of what we call bottom-up process. We start with sub-district level. We calculate the proportion for each growing patch of paddy, and then we go further to get we scale up, yeah, to get provincial and national picture. Yeah. After that, after we calculate the proportion, we take the average of the proportion. Yeah. We take the average of proportion. Again, we do this process in each sub-district level. Yeah. Sub-district level, the ultimate level in our hierarchy, yeah, of observation. Yeah. We took the average of the proportion, and after that, we just multiply the proportion of each growing pace. We just multiply by the field paddy area that we already have. Yeah, and after that, of course, we can get the estimation of the area for each paddy growing pace. Yeah. That's the whole process of data processing to estimate the area of the paddy of the growing pace of paddy, yeah, including the harvested area. And as I said before, we also have integrated our area sampling frame survey to our crop cutting survey to estimate the productivity, the yield per hectare of paddy. Yeah, the previous method, as I said before, the previous one we use list frame in conducting the survey, and this process came with some limitation of or drawbacks. And after the integration with the area sampling frame, when we use the result of our area sampling frame as our sampling frame, we can solve those kind of drawbacks. Yeah, and the one point that we have after we integrated our crop cutting survey with our sampling frame, area sampling frame survey, we come up with a better distribution of the sample. So in terms of representativeness, we have a better distribution, sample distribution. Yeah, better representativeness. This is the illustration when we have crop cutting survey that is integrated with area sampling frame. Yeah, so simply speaking, the plot of the crop cutting experiment will be the sample segment. Yeah, will be the sample segment. In this slide, I want to explain why we can use the result of area sampling frame for our crop cutting survey. Yeah, basically, as I said before, in conducting observation in our area sampling frame survey, we record some information, not only the harvest but also the growing pace, the growing pace of the paddy. Yeah, the stage of the development of paddy. Yeah, and actually from this information we can use it as our sampling frame for crop cutting survey. Yeah, because from the area sampling frame survey, we collect information about uh, the growing pace in vegetative 1, vegetative 2, and also generative. We can use this kind of information to construct our sampling frame. I will show you the intuition behind this 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 picture. Yeah, actually we use what we call calendar, the calendar of growing pace of paddy. Yeah, because paddy in vegetative 1, based on our experience, of course, it is a little bit generalization that paddy in vegetative 1 probably, possibly will be harvested in the next 3 months. And in vegetative 2, probably will be harvested in the next 2 months. And when paddy in generative, they will be possibly will be harvested in the next month. Yeah, I will show you the calendar, the intuition that we use, yeah, for this. Yeah, this is the rice growth pace calendar that we use. Yeah, from this information, we come to conclusion, decision to use the result of our sampling frame survey for our crop cutting survey. Yeah, as you can see, yeah, actually based on the lifeline, the lifeline of the paddy, of the plant, yeah, of the paddy, yeah, of the paddy. Yeah, as I said before, vegetative ones probably will be harvested in the next 3 months and so on. Yeah. This slide show you the result that we produce, yeah, from our area sampling frame survey. Yeah, so we can produce what we call monthly growth pace monitoring. Yeah, we can conduct it by province. Yeah, we can produce this picture, this map. So from this map, everyone, especially our data users, can identify the location of in which location paddy, for example, is in vegetative 1 or vegetative 2 or harvest and so on. Yeah, and from this kind of information, I think a better decision-making policy can be made, yeah, by our stakeholders, our data users, especially not only in national level but also sub-national level, province. Yeah. So this kind of picture is very useful for them in terms of growth pace monitoring of paddy. Yeah, we also produce this kind of table. Yeah, as I said before, we can estimate, yeah, the area of paddy for each growing pace. Yeah, not only the harvest. We also can estimate the area of damage, land preparation, and so on. Yeah, and we can present the result. We can provide the result of estimation on a monthly basis. Yeah, until provincial level. This is just a continuation of the previous table. Yeah, and one of I can say it, the benefit of using area sampling frame, the main advantage is we can provide what we call the potential harvest for the next 3 months. Actually, it is kind of forecasting, you can say like that, but in this case, we do not use statistical model. Yeah, we just use the analogy of the rice growing pace calendar that I have presented to you before. Yeah, so based on that calendar, we can produce kind of estimation or prediction. We call it a potential harvest for the next 3 months. And based on our evaluation, actually, the accuracy is not bad. Yeah, it is acceptable statistically, because I think the accuracy, the deviation on average is less than 10%. Yeah, so it is quite good. And also this kind of information is very, very important, very useful for our data users, for the sake of mitigation, for the sake of what we call early warning system and so on. Yeah, and we are proud to say that our result from our area sampling from survey can contribute to decision making, yeah, on policy making related to rice commodities in Indonesia. Yeah, our data users not only from government agencies but also from private sectors. In this slide, I just show you some example of our data users from ministerial agencies. Yeah, for example, the Ministry of National Planning or Bappenas, they use our result for determining budget allocation for development programs related to agriculture sector. State Logistic Agency or Bulog use our information for our data for stock management and price stabilization. Ministry of Trade for rice importation policy, Ministry of Finance for budget determination and evaluation of fertilizer subsidy, and also Ministry of Agriculture for crop monitoring, program planning and evaluation on paddy, and also Ministry of Public Works and Housing for evaluation of the irrigation system in supporting rice production in Indonesia, and many more. Yeah, other institutions and even state-owned companies. Yeah. However, as my deputy chief statistician mentioned before, there is no one single perfect method when it comes to crop estimation, crop area estimation, and the same applies to area sampling frame that we implement. Yeah, we have some issues, we have some challenge. We hope our USDA team, with their experience in implementing sampling area frame for a long period of time, can help us, can give us some advices, some comments, how to deal with those challenges. Yeah? The first one, yeah, there is no sample rotation so far. Yeah, we have implemented the method since 2018, and until now, there are no sample rotation. Yeah, we read from some papers published by USDA that you conduct a kind of sample rotation. I think this is a good idea for guarantee for capturing, yeah, the variation on the ground. Yeah, but for us, the same segments have been observed since the first implementation in 2018. Yeah, we only conduct what we call sample replacement for only the non-eligible one. Yeah. Second, the need to capture more variation on the ground. Yeah. I think it is related to the sample size and distribution. Yeah, the sample distribution. Of course, this one is closely related with the previous one. Yeah, if we imagine if we can do kind of sample rotation, and actually we want to learn more about this process from USDA. If we can do this process, we believe that we can capture more variation on the ground. Yeah. Yeah, we will have a better sample distribution. Statistically, of course, to capture more variation, one thing that we can do is by increasing the sample size. But yeah, the problem is that kind of option is costly. Yeah, you know, because as you can see from my previous presentation, we rely on our surveyor to do field observation, and there are many of them. Yeah, with a high cost of operational cost. Yeah, with a high operational cost for certain areas. Yeah, so increasing the number of sample segment is costly. Yeah, for us. Yeah, since the reliance on the field observation, yeah, conducted by, you can imagine we have 1,000 surveyors. Yeah, to do observation. And also the need to provide a small area estimate, yeah, for the harvested area, because our data users, for example, the Ministry of Agriculture, for the sake of program monitoring and evaluation, they need a more detailed picture until sub-district level. So we can learn, maybe we can learn from USDA. Maybe all of you have experience in providing a small area estimate, yeah, using the result of area sampling frame. Maybe you have kind of model, statistical model, to produce this kind of estimation, yeah. And the last one, misidentification of paddy growing pace by a surveyor still happens, yeah, because we still use a observation. Of course, we do some trainings, yeah, to make sure that our surveyors can recognize the growing pace of paddy when they conduct field observation precisely. But as human, you know, misidentification can happen, yeah. So we still deal with this kind of issue, yeah. And this is our plan in the future to improve our area sampling frame survey. So we, as my deputy chief statistician, Pak Habib, say, at the moment we are replicating the method to maize commodity, yeah, and we want to replicate to other commodities, broader commodities, yeah. And the result of implementation for maize will be available next year, hopefully. Also, we plan to implement what we call machine learning, yeah, on satellite imagery in identifying the growing pace of paddy on sample segments. So, as I said before, one of the issue is misidentification by our surveyor. So we want to solve, we want to eliminate this problem by implementing what we call machine learning. So the growth pace, we expect the growth pace will be estimated automatically, yeah, using kind of algorithm model, statistical model, using the satellite imagery, the image of the sample segment location, yeah. Yeah, our dream, it can replace field observation in the future. And the last one, maybe I think remote sensing is a good choice, a good option, and we want to implement this kind of new method as an alternative for some specific areas. Because as I said before, the issue with our area sampling frame is, we can say that maybe to some extent the method is not cost effective. Yeah, so we want to remove some of our burdens in terms of cost by using remote sensing for specific areas. And actually, related to these plans, we want to learn more about, we want to learn more from the USDA. Your experience in, for example, in use remote sensing for crop estimation. Maybe you have experience in developing machine learning, statistical model to using NDVI, things like that to identify the growing pace of crop. Yeah. I think that's all from my presentation, and we are happy to take any question from all of you. Thank you.
Thank you very much, Pat Kadir. We do have some questions for you. And for NAS people, please feel free to keep adding questions into the chat. I'm going to start from the top of the chat and start sharing the questions. All right, so the first question is on the paddy field map that you used back on slide 5 or 6. The question is, what is the source being used for this paddy field map? Is it a classification map based on collected paddy data points? And that's back the 4 data inputs, or the data inputs that you had to the stratification process.
Okay. Thank you, Sarah, for the question. For paddy field map that we use in constructing our sampling frame, actually, we got the map from other government agencies. They are government agencies that specifically developed the map. Yeah, actually we don't know exactly about the process, the technicalities, and developing the map, but some of my colleagues actually got involved in the process of developing the map. I saw Mas Dena Drajat here. Maybe can help me to address this question, yeah, because he has experience in this area. Maybe Mas Dena can help me to address the question.
Okay, thank you. There is some issue here. About the source of being used for the paddy field map, we get the paddy field map from other agency, but we know they are using a lot of source. Some are very high resource satellite imagery, like GeoEyes, Iconos, QuickBird, and WorldView, but most of them using high resolution satellite imagery like Spot 5 and Spot 6. And then they do some classification. Some of area is checked on the ground, but most of them do by digitizing of those agency.
Okay. Justin, does that answer your question?
Yes, that answers it. And I probably can delve into that a little bit later, probably on another session, as to move forward with other questions.
All right, thank you. Our next question. Our next question is on the dryland arable strata. What non-rice crops might be in these segments, and do they grow other crops mixed in with the rice?
Yeah, thank you for the question. Actually, we can say that this is one of the main weakness of our, when we constructing our area sampling frame, yeah, because we only have, as I said before, paddy field map means that we only have wetland paddy for wetland paddy. We call it sawah in Indonesia. For the dryland, yeah, this is one of the whole of our method, because we don't have what we call kind of map like wetland paddy or dryland paddy actually. And actually we combine some information to get information about the location of the dryland paddy, because we don't have a kind of map like wetland paddy. From satellite imagery, we don't have kind of map, and yeah, we just rely on other information. At the same time, we have administrative data collected from registration process conducted by the Ministry of Agriculture, so we can use the information of the dryland paddy cultivated by paddy, and we combine with our information that we have for paddy field map, yeah, wetland paddy field map. And of course, in Indonesia, mixed crop is a normal practice, yeah. Especially in the dryland, you can find not only paddy there, yeah. But in terms of paddy, I think when the farmer cultivate paddy, they only focus for one kind of crops at the time. Yeah, I mean, there is no possibility they will combine paddy, and maybe the possibility is very small. Yeah, they combine paddy and other commodities at the same time. Related to how how we construct the stratum tree, yeah, the stratum tree for dryland paddy. Maybe Mas Dena, again, Mas Dena actually the real expert, yeah, of this area sampling frame, especially the process of constructing the area frame. Maybe Mas Dena can help me, can give me hand how to explain related the dryland paddy, yeah. Maybe you can add some comments about this question.
Okay, about the dryland rebel strata, we don't have a special map to get this strata, but we do try to cover them in our area sampling frame, because there are some rice crop there. Yes, like Sarah said, is there any other crops, non-rice there? Yeah, we have other crops and we identify them. There may be, we made some classification also, Mr. Kadir, but not show the map here. We have map of some other crops like bean, corn, tobacco, and maize, and etc. We have the map maybe in other presentation we can show to them. We still have a lot of time to study together.
Thank you. Thank you. Our next question is about the surveyors. When they go out to these subsegments and they're taking their pictures, do they need to contact the operator of the land before they start visiting?
Not at all. Yeah, not at all. Not at all. We can say that the observation of the sample segments is contactless. Yeah, we don't need any information related to the farmers, the contact, things like that. Our surveyors just make a visit to the location, because as I said before, the location of the sample segment is easily identified because each sample segment is equipped with georeference information. Yeah, all they need just to bring their device. Yeah, they can track the location of the sample segment using the application. Yeah, installed in their device. Yeah, but For crop cutting survey, this is the different, this is a little bit different, yeah? For crop cutting survey, because we have to conduct what we call crop cutting experiment, we need information about the farmers. But yeah, but for area sampling frame observation itself, we don't need information about the farmers, the contact numbers, things like that.
Thank you. Thank you.
Yeah.
Next question is, can you explain what factors are being observed from the supervisor to monitor the crops based on input from the surveyors, such as weather? And Justin, you may need to explain that question a little bit.
Yeah, so I was trying to understand, after the input from the surveyors get uploaded to the servers, that goes to, I guess, the supervisor. If I'm getting the terminology right in regards to the process, then it was said that the supervisors essentially perform a methodology of assessing the inputs from the surveyors, and it was a course period of time that the supervisors look at different models within the platform. I guess it's probably an internal platform, and how they will provide or assess conditions based off of the inputs. And my question was, what assessments or what models are being looked at or being viewed or assessed throughout that process when the data inputs are uploaded to the servers?
Yeah, thank you, Justin. Yeah, actually, our supervisor don't use any specific statistical model in assessing, yeah, the result of observation sending by their surveyors. Actually, they just do the same process as the surveyors, but from the website, not on the ground. Yeah, they just look at the picture, checking the consistency of the picture with the report of the surveyors. Yeah, our surveyors just send their report after they identify the growing phase of the paddy. They send to the server some codes, yeah, some information about the condition of the paddy, and at the same time, they also taking picture and send the picture. The task of our surveyors is just to make sure that the picture match with the growing pace reported. So simply like that. There is no statistical model, things like that. Just to make sure that consistency between the picture and the real condition reported by our surveyor. I think maybe hopefully my explanation can address your question, Justin. Yeah,
yes, it definitely does.
Yeah, thank you.
No, yep, thank you so much.
Thank you, Kadir. The next question is related to the estimation process. You had shown that if it's in the generative phase, it gets a 1, but if it's in one of the vegetative phases, it is a 0. My question is, what if rice is not found in that subsegment? Would that be a 0 as well for that subsegment, or do you treat it somehow differently?
Yeah, maybe Mas Dena can help me to answer this question. But from my point of view, actually, we apply the same treatment, the same model for each growing phase. Yeah.
Okay.
For each kind of what we call the condition that our surveyor report to us. Yeah. Actually, there is no specific treatment for condition when the observation result is not ready field. Yeah. Yeah, we apply we apply the same process in doing data processing, in calculating the proportion and also the estimation of the area. Yeah, hopefully can address your question, Sarah.
Okay, so just to make sure I understand, the example that you gave us would only work for calculating area harvested. It wouldn't, you know, you would have a different set of rules where if you were trying to get vegetative 1, that would be the thing that is a 1 and everything else would be a 0, but you would use the same type of calculations. I understand.
Yeah, the same calculation. Yeah.
Okay, thank you very much. Next question is, for the calculated area harvested, what methods are performed for validation? Justin, do you want to explain what you mean?
Yes, and it could be my mistake because I was trying to understand the slide that was utilized when I think it was estimation or area harvested estimations were given, and I was trying to again think about the slide and I wanted to see after you derive a number for the calculated area harvested for that growing period, and reverting back, is there any way or is there any process used to verify or to validate that number? Maybe do you have farmer surveys that are used to see how close you are with your calculated number?
Yeah, thank you. Thank you, Justin. Of course, because after we estimate the harvested area, we have to disseminate our data. We have to send them to our data users. Of course, before that, we have to make sure that we come with, you can call it a correct number, things like that, that can represent the field condition. Of course, there is a process to make sure that our estimation is what we call, we can share the estimation. And for this process, actually, we don't have any specific survey to support our validation process, but yeah, actually we use other information, as a comparison, just for the sake of what we call to collect phenomenon, things like that, so we can confident with our numbers. So we just collect information from other sites, from internet, for example, just to get the sense what happens in the particular time when in the particular time to support our justification. Maybe I can say like that. So actually, we don't have any specific survey, any specific process to conduct validation on our estimation result on harvested area. We just rely on other information to support, to maybe making justification so we can confident with our number. Yeah, hopefully can address your question, Justin.
Yes, it does. Thank you so much.
Maybe we can learn from USDA about this issue. Maybe you have something, you have a model or system to verify, to validate your estimation results, so you can confident with the number. We are happy to learn more from you about this issue. I think this is very interesting. That can help us, to improve our how to disseminate our result. Thank you.
Thank you.
Thank you.
The segments you said are 300 meter by 300 meter, and the sub-segments are then 100 meter by 100 meter. What is the average size of a paddy field? Like, is it bigger than a sub-segment? Is it, would you have, 10 paddy fields inside a segment? What is the size of a paddy field in relation to the sub-segments and the segments?
Yeah, actually, it depends on the condition on the ground. Sometimes the whole square is paddy, but it happens that only half, even maybe a quarter of the square is paddy. Yeah, I think this is one of limitation of our method. Yeah, actually, not all of our subsegment samples are paddy. Yeah, 100%. The
Sure.
whole square is paddy. Sometimes half, even less than that, is not paddy. Yeah.
Okay, thank you.
Yeah. Yeah, actually, and related to this issue, actually, we need some, maybe USDA team can give us some comment advice, because this issue is related to the estimation process, yeah, the accuracy of estimation. Because we assume that in practice, we assume that all subsegments are petty, but in reality, sometimes, as I said before, half of them, even less, is not petty. Maybe we want to increase our estimation actually in this regard, and hopefully the USDA team can help us. Yeah,
Mhm.
can help us in this issue. Thank you, Seth.
Thank you. Thank you. The information that you've been showing us, is it released to the general public? If so, how frequently, how often? And then I also want to know at what level do you publish harvested area? Is it district level? Is it, at what level do you publish?
Yeah, actually, we release the result officially, but the frequency is not every month. Actually, we just release the figure 2 times a year, 2 times a year. But actually, we provide our result to our what we call other government institution. Yeah, we send them our result on a monthly basis. But for the sake of publication, press release, we just conduct it 2 times a year. And related to the level of that we present, we just provide information until provincial level. Actually, yeah, we just provide until provincial level and national level. And of course, we select some information that we can publish. We just publish information related to harvested area from the result of our area sampling. Yeah. But for other government agencies, they can access more detailed information every month. Yeah, the estimation result not only for harvested area, but also for other growing pace. Yeah, yeah. I think I hope my answer can help you to answer your question, Sarah.
Yes, it did. It did. Thank you. Next question is about the damage category that you showed us, and it varies by month. Is that associated with a seasonal weather drought or monsoon season?
Yeah, yeah. Your question is very, very difficult to answer actually. Yeah, based on our evaluation, the result of estimation for damage, yeah, the area of damage is, we think is not strong enough, because at the same time we have other information, yeah, from news, things like that, from the Ministry of Agriculture, for example. Yeah, maybe our estimation is a little bit underestimation compared to the reality, yeah, things like that. And that's one thing. The other thing is actually the definition of damage. Yeah, we have to formulate a strong definition, yeah, of damage. Yeah, yeah. In practice, our surveyor have don't have a strong what you call understanding classification, yeah, to determine whether this categorize damage or not. Yeah, I think we have to improve this kind of issue. Yeah, but yeah, actually, from our result, the estimation of the area of damage, at least we can provide an indication, things like that. Yeah. Of course, maybe the level of estimation must be it must be improved, but at least there are useful information for our data users, especially the Ministry of Agriculture. They can identify the location, yeah, the location. Yeah, so we not only provide the estimated area, but also we can provide them with the location, as you can see from the map that I showed to you before. Yeah. Okay, maybe Mas Dena maybe can add some comment related to this.
Okay, thank you. About the damage criteria. Sorry. About the damage category, in our survey, we only assess the damage to the plant that already in the field. So mostly it's because some flood, not because of drought, maybe our monsoon or other. Mostly because of the rainy, then flood, and also the pests that make the damage to the plant. But we don't really enough experience to get the damage because of drought. Thank you.
Thank you. Thank you both. Next question is on quality control checks. You mentioned that identifying the growing phase is sometimes misidentified by the surveyor. And you've also mentioned that when the photos are sent in, sometimes someone reviews them to see that they are out of phase. And certainly I would imagine if you go back out the next month and the month after that, you would know whether they had originally misidentified the growing phase. My question is, in the 5 days that they're taking the photo, does anyone else come out and do a quality control check by actually going out to that field within those shortly thereafter to see if they have identified the growing phase correctly?
Yeah, actually, there is no process like that. Yeah.
Okay.
Actually,
okay.
Yeah, our supervisor they just rely on the website, the tools on the website to do assessment, things like that, validation, as I said before. And when they find a kind of inconsistency, things like that, something wrong, indication, things like that, they will send the result immediately to the surveyor. Yeah, they will send the feedback. Yeah, and hopefully after that the correction can be done immediately. So yeah, we complete the process of validation assessment as I said before, in 5 days after the observation period. And based on our experience, this mechanism worked very well, actually. And actually, based on our evaluation, the percentage of misidentification actually relatively small compared to the whole samples, maybe less than 10%. But when it comes to subnational level, it can become an issue, actually. But based on our experience, 5 days time is enough, yeah, to do the validation. Thank you.
Thank you. Next is actually more of a comment and then more questions. So the comment is, from experience, field observations will still be needed to validate machine learning techniques. So even if you guys want to move towards doing machine learning, you'll still need field observations. And then the question is, how much farmer input goes into surveys? And Justin, you may want to explain that a little more.
Yes, and I think it was actually noted earlier by Pat Kadir, and
Yeah.
saying that when the, oh, I'm sorry.
No, keep going, Justin.
Okay, yep, I'm sorry about that. So when the surveyor goes to the farm, if they actually talk to the farmers and input or incorporate some of the farmers' knowledge of, how much area, of rice they're growing at that certain time frame, what phase, the crop is in, some of those verification aspects. But I think Pat Kadir noted earlier that the surveyors essentially go to the farm, pretty much unannounced and take their data collections. If I heard that correctly.
Yes.
Yeah, maybe I want to add some comments related to this question. Actually, as I said before, we also have the crop cutting survey at the same time, to estimate the yield. Actually, in crop cutting survey, we do that kind of process because we have contact with farmers. We ask them not only the area, but we ask them many questions related to the cultivation process. We ask about fertilizer. We ask about factors that can impact the cultivation, like damage, disaster, things like that, actually. But for the area sampling frame, less contact with farmers. We only need to take picture and observe the growing pace in the sample segment.
Thank you.
Thank you.
Thank you.
Looks like the last written question is, how well have the field observations in the different growing stages correlated with your satellite imagery? And I'll add another question of, do you make that comparison at all currently?
Yeah, actually, at the moment, we are conducting a small study, small study. We call it a sampling area frame hybrid, just a jargon for us. Actually, we try to combine what we call the result of area sampling frame with the remote sensing. At the same time, we have the result of field observation for a certain sub-segment. And at the same time, we have the result of using machine learning, NDVI, things like that, to identify the growing pace. Based on our study so far, actually the result does not. I mean the accuracy maybe still need improvement, things like that. Maybe we have to improve our algorithm, our model, things like that. But we are doing kind of process at the moment, Of course, actually, I think we need more improvement, to get a better result in using remote sensing to identify the growing pace of paddy. Sometimes field observation do better based on our study.
Okay.
In many. Thank you.
Yeah, thank you. That was all of the written questions. Do any of my USDA colleagues have a question they want to ask now? Get off the camera.
I mean, I would ask the question in regards to the confidence level that BPS has with their area frame surveys right now, although it is noted that there is room for improvement, but just to see what the confidence level is in their current methodology.
Yeah, thank you for the question. Yeah, actually, intuitively, we are very confident with our method. Of course, at the same times, we have, you can call it statistical, yeah, measurements, yeah, to to assess the accuracy of our estimation result. We have coefficient of variance, and our coefficient of variance for harvested area estimation, I think, is quite good. On average, on national level, I think maybe less than 5%. So based on that, we are pretty confident with our estimation result from our area sampling frame, actually. And also, we do some analysis, yeah, to make sure that our figure have a coherence with other variables. Yeah? For example, export and import, and also the price, the development of price of paddy, things like that. And based on our analysis so far, I think there you can see the coherency, yeah? And we are confident with that, that our results have, have, have described the reality quite good. But of course, as Justin said before, there are a lot of, we need more effort to improve our result. There is room to improve the method in the future. And that's why we need some input, some comments here, maybe in the next session from the USDA team. Thank you.
Thank you. This has been some excellent information. I really appreciate that you actually specified some things that you would like to hear more from us. That will help us tailor our future presentations to the areas that you're particularly interested in. I will probably myself have a few more questions, but I need to think about it a little bit and maybe re-watch this recording. So we may send you some more questions in the next day or two. I expect that we will send them to Ugi, and Ugi will then pass them on to BPS.
Yeah.
I don't think Garrett is back yet from his meeting. Garrett, if you are, please jump in. All right, well, we definitely want to say thank you. This has been some excellent information. I remember that this was a problem when I first went to Indonesia, and it's fantastic to see how much progress you guys have made on improvements. That's just excellent, and I think you'll get a lot of knowledge out of what we do. What we do is not going to be perfect. Nobody has a perfect statistical system, but just the exposure to different ideas and you know, maybe it'll make you think of something new or a different way of doing something that could be helpful to you. That's one of the goals. Other than that, if there are no further questions or comments from anyone, we could call it a morning or a night, depending on where you're sitting. I will send out the recording in the morning. So I guess you guys have been getting these about a day late, just due to the time zone changes. But I will send you the recording in the chat and all that good things. Let's see, somebody just added something to the, Justin just added, thank you again, Pak Kadir. The presentation was very informative, and I concur, absolutely very informative, excellent information.
Yeah, no worries, no worries.
Okay. All right, going once, going twice, 3 times. Any final comments? Well, in that case, thank you very much. And we look forward to the next session, which will be in 2 days. Ugi, did you need to say anything to? for the next session or about anything?
No, but I think Clement might want to say something regarding the survey.
Yes. Thank you, Ugi. You read my mind. Yes, please. Just a reminder that we received about 46 responses to the survey on the GADAS training, and there were 87 who opened their emails. I hope you got the reminder emails. So please fill out the survey. I think it took them an average of 10 minutes to respond. So those of you who are here who have not responded, please please do so. And if you know your colleagues as well, later on, if you could just spread the word around to fill out the survey. Thank you.
And that survey would be just for the GADAS talks.
Yes.
Obviously, we would not expect BPS to evaluate a talk from BPS.
Oh, no. This was the survey last Friday. And
right.
So we sent a reminder, I think the reminder email came out today. I know there are only about maybe 20 here from BPS, but if you know your other colleagues who may have attended the GADAS training who are not here, to please let them know.
All right.
All right.
Well, again, thank you all for participating tonight, and we will see you in about 48 hours. Thank you. Good night.
Thank you.
Thank you. Good night.
Thank you, Sarah and BPS colleagues. Good evening.
Thank you, BPS colleagues.
Thank you.